A great man once said, go deep down into anything and you'll find mathematics. Ramsey numbers are the part of graph theory. Basically, the question it answers is, if you give some information about a system, what patterns could you expect? We all know how to play tic-tac-toe, right? Two players take turns marking the spaces with X's and O's. The goal is to get 3 in a row, whether horizontally, vertically, or diagonally. Let's take this match which ended as a draw. There's no way to decide who won, right? Yes, that is true, but that's only when you're playing in 2 dimensions. But when you play in more number of dimensions, like this version, even though all the matches ended up as draws, somehow I have a weird diagonal where it's 3 in a row.
It doesn't stop at 3 dimensions. I mean, imagine a version of this game where there were 3 copies of the 3-dimensional tic-tac-toe. Even after randomly generating all the matches, you can still see many rows of 3. This is an example of a straight line in the 4-dimensional case.
This is all explained by Hales-Jewett's theorem. It states that no matter the length of the lines you choose, and regardless of the number of players, there's always a high enough number of dimensions that will guarantee a combinatorial line. This means that in these variants of tic-tac-toe, a win is always possible. The idea of Ramsey numbers was introduced by Frank Ramsey in 1926. Later, Paul Erdos found some limits to these numbers, but he couldn't find the exact number. Let's say you're throwing a dinner party and you want to have 3 guests who know each other, or at least 3 strangers. How many people would you have to invite? I'll draw a blue line between 2 people who know each other, and red if they don't. Now here's the interesting part. No matter how we draw these lines, we'll always find a triangle with either 3 people who know each other or 3 who don't. This is guaranteed to happen in every possibility, kind of reminiscent to our theory in tic-tac-toe. Let me explain why. Each person has 5 lines connecting them to everyone else. Since there are 5 lines, at least 3 of them have to be the same color. So no matter what, you'll end up with a triangle which is either blue or red. So the answer to this question is 6. Last year, a team of mathematicians had a breakthrough using Paul Erdos' work to sort graphs and find patterns. They helped reduce the upper bound of the Ramsey number exponentially. They created a new method to solve many of the world's mysteries.